In this unit, we're going to take a look at the universe and the things that make it up, the Big Bang Theory, how planets form, how stars form, and what's going on when stars die. And to get familiar with that, we want to take a look at things that are in the universe and what we mean when we talk about the universe. So when we talk about the universe, we mean everything, from the smallest little subatomic particles like electrons to the hugest galaxies that are made of billions of stars, and all the space in between. That's what we mean. There are some things in the universe that you guys are familiar with because you can look up into the sky and you see them. At night, you look up into the sky, and probably the most prevalent object in the sky is the moon. Okay, the moon is small. It's small compared to planets. It's tiny compared to the sun. It's little, but it is fairly close to us, so it looks big. We're not the only planet with a moon. Mars has two moons. The outer planets all have several moons. So a moon, by definition, is just a body that orbits a planet, a chunk of rock or gas or dust or whatever it is. It's all stuck together and it orbits a planet. A planet is a body that orbits a star. A planet has to meet three criteria. It has to be spherical in shape, it has to orbit a star, and it has to have cleared its local neighborhood of debris. What that means is if there's other stuff floating in space next to it, it needs to be in orbit around it. So the moon is stuff floating in space next to us. It orbits Earth. So we've cleared our local neighborhood. We've put everything under our control. Above planets are stars. Okay, stars are giant. They're huge. And what defines a star is that it's a luminous body. Luminous means it makes its own light. So stars shine in the night sky because they make their own light. Um, Carries out nuclear fusion. That's what makes the star so bright and makes you able to see it. It's actually fusing hydrogen into helium, and that produces lots and lots of energy. So that's what we see. The sun is, of course, a star. Then above that we have solar systems or planetary systems, and this is all the stuff that orbits a star. So our solar system has 8 planets plus Pluto plus asteroids plus um, comets, so all kinds of things that orbit the sun. That's what makes up the solar system. A galaxy is hundreds of thousands of millions of stars, so lots and lots and lots and lots and lots of stars that all have a common center. They're all orbiting around a common thing in the middle. And so from smallest to biggest, moons, well, they're little, they orbit planets. Planets are a little bit bigger, they orbit stars. Stars are quite a bit bigger. They orbit the center of a galaxy. There are some stars that float around kind of separate from other things, but most stars are in galaxies. Then solar systems are the sun and the star and everything that orbits around it. Then we have the galaxies that are made up of solar systems and stars and hundreds of thousands and millions of things. Okay, our solar system is actually out in the corner of the Milky Way, and the Milky Way galaxy is a spiral galaxy, and we'll take a look at that. Okay, so how big is the universe? Well, the universe is big. Okay, this picture is called the Hubble Deep Field, and to make this picture, what scientists did was they took the Hubble telescope, which is a telescope on a satellite in space, and they pointed it at a dark little corner over in the Big Dipper region of space, and they took a picture. And this represents 1/24th millionth of the sky. 1/24 millionth of the sky. So if you had a tennis ball about 100 meters away, this is how much space it would occupy. So this is a tiny little chunk. That's a fairly dim, dark part of the sky. All these little specks you see in here, these are not stars. Okay, you can clearly see that. That's not a star. That's a galaxy. Most everything in this picture is a galaxy. They're so far away, they're outside our galaxy, which means in order for us to see them, it's got to be lots and lots and lots and lots of light. So every one of these dots is made of trillions of stars. So this is space. This is looking out into the universe as far as we can see. And there's actually several other images that the Hubble has taken like this, pointed in different directions, and space basically looks uniform in all directions. The universe looks fairly similar to us no matter where we look, which is kind of neat. So, the Hubble Deep Field shows us a very small part of space, and space is mostly empty space, and there's lots of galaxies and stars and stuff in it. Okay? if we take a look at some galaxies in a little more depth, these are a couple of spiral galaxies. This is called the Whirlpool Galaxy. This is a barred spiral galaxy. This is a ring galaxy. All of these are made up of trillions of stars. So these glowing streams in here, those are actually lots, and it's like it's like a cloud of stars in here. So you're looking at lots and lots and lots and lots of stars. And galaxies do come in different shapes. We're not going to get too worried about them all, but they generally do have a nice common dense center. And in fact, the Milky Way galaxy is a spiral or barred spiral galaxy, and the theory is that the center of it is a black hole. Okay. Now, we're going to take a little bit closer look at our solar system, and I do want to run through this really quick. Okay. We have inner planets, outer planets, and the sun, and then some other junk floating around as well. So this top picture up here shows us the inner planets plus Pluto. We'll talk a little bit about Pluto. Mercury is the closest planet to the sun, then Venus, then Earth, than Mars. You'll notice Earth and Venus are similar in size, but Earth is the biggest planet of the inner planets. Mars is fairly small compared to Earth. Venus is close, but its atmosphere is pretty nasty. We couldn't survive there very well. Okay, then we move to the outer planets, which are down here, and these are to scale. So here's Earth, the biggest planet up above, is fairly tiny compared to these outer planets, Neptune, Saturn, and they don't have the rings on Saturn because it makes Saturn too big to fit in the picture. And then Jupiter. Jupiter is fairly large. Then over here we have the sun. Okay? The sun is giant. Here's Jupiter. Here is Earth right here. It's tiny little guy. So the sun is huge. The sun is an average to low mass star. So it's a star, but it's not a giant star by any means. There's actually a few more pictures in this series, and you can see stars that are like make the sun look like the Earth. So our Earth is a tiny little planet next to a giant sun, and our sun is not a giant star. Okay, so let's take a quick look at the solar system so we're familiar with some of these things. Here it is in a nice little pretty picture. Now this is shockingly not to scale, but the Earth is 98 million miles away from the sun, so trying to put it in scale and getting it to fit on a picture doesn't work. But it is worth noting that the planets do orbit all in a common plane called the ecliptic, which is sort of interesting. You can see our inner rocky planets. We've got Mercury, Venus, Earth, Mars. Then we have this asteroid belt, which is a bunch of chunks of rocks. And then we have the outer planets, Jupiter, Saturn, Uranus, and Neptune. And then they do have Pluto orbiting way out there. Okay, so sun is central in the solar system. In fact, the solar system is not quite circular; it's elliptical, but close enough. There's 8 planets that orbit the sun. Like I said, the 4 inner ones, 4 outer ones, and a whole bunch of other junk. The inner planets are all rocky. They're called terrestrial planets. They're made of heavier elements. We've got lots of iron and metals and heavy things, not very many gases. We have a very thin atmosphere. So they're small, they're rocky, they're close to the sun. Not very common to have moons on these things. Because, well, we'll look at that in a little more detail, but just there's not very many moons on the inner planets. So those planets are Mercury, Venus, Earth, and Mars. Okay, then we have the asteroid belt, chunks of rock floating around out there. And then after the asteroid belt, we have Jupiter, the outer planets. So these are the gas giants. These are very large planets. They have lots and lots of mass. They're far away from the sun, and most of them have lots of moons or rings. So there's just more stuff orbiting the planets out there beyond the asteroid belt. Okay? So Jupiter, Saturn, Uranus, Neptune, they're all out there. But Pluto's out there as well. But we don't count it as a planet, at least not anymore. Okay, and that's because as we learned more and more and more about space and what's out on the outer edge of the solar system, it became clear that we really needed to have a definition of a planet. Pluto is out in a layer of stuff called the Kuiper belt. Okay, so that's said Kuiper, and it's basically a bunch of chunks and little pieces, some are similar in size to Pluto, some similar in size to Ceres, which is a big asteroid looking thing. these are all on the outer kind of edge of the solar system, and they're all out there together. And because this Kuiper belt is lots of things and they're not all orbiting Pluto, Pluto doesn't make the qualification as a planet. So it was either demote Pluto to a dwarf planet status or try to add all these little things that are out there to the planet list. Um, Pluto doesn't qualify as a planet because it hasn't cleared its local space of debris.